Hello and welcome to the second video in our lecture on digital envelopes and pseudo-random number generators. Remember that in the previous video we discussed one more application of public key cryptography, which was digital envelopes. Now in this video we're going to talk about a seemingly completely different topic, namely random numbers. But the goal of this video is to convince you that actually there's a very strong connection between public key cryptography and cryptography in general and random numbers. In particular, it turns out that many computer security algorithms, in particular network security algorithms, used random numbers in a variety of places. So I want to discuss a few applications. Some of them we've already discussed and some of them we have yet to discuss. So first, remember public key encryption algorithms like RSA and also Diffie-Hellman, which is not used for encryption but for distributing and sharing private keys. So these are two examples of public key algorithms that both use random numbers. Now remember that in RSA, the first step is to generate two large random numbers, P and Q, to be used later on in the algorithm. Similarly, in Diffie-Hellman, we start out with a big random number Q and then also alpha, which is a primitive root of Q. So these are two very well-known and very much used algorithms that make use of random numbers. As a second type of application, let's remember the discussion we had about symmetric stream ciphers, in particular the RC4 algorithm. Remember that the way these algorithms work is they're basically a practical version of the one-time pad, where the message to be encrypted is XORed with a random key, a sequence of bits that's as long as the message. So the way this algorithm worked, we would start with a fixed length key that would be fed to an algorithm that would be called a key stream generator. And this algorithm would be outputting a key stream that would be XORed with the message to be encrypted to produce the ciphertext. And so this key stream is really a stream of numbers like the one-time pad that is then XORed with the message. And so this stream of numbers has to be a stream of random numbers. So again, the security of this RC4, or more generally this symmetric stream cipher, is based on this stream of random numbers. So that's a second application in cryptography of the use of random numbers. A third one is the one we discussed in the previous video, namely the digital envelope mechanism. Remember that as part of the first step performed by the sender, one of the components was to generate a symmetric key, which had to be a sequence of random bits. So again, we have to somehow obtain some random numbers here. Now, these are applications that we already talked about. The fourth one is something that we have yet to talk about, but these are scenarios called key distribution scenarios in some popular security suites where we have either a key distribution center or some kind of a handshaking protocol that requires the use of numbers called nonces. So a nonce is a number that is used only once. So that's where the name comes from, nonce. And the reason these numbers are important is because they are used to prevent what are called replay attacks. So a replay attack is when the attacker intercepts a communication or a message stores it, and then uses it later to reinitiate a communication with the receiver by simply replaying or resending the messages that they captured earlier. And one way to prevent this kind of attack is to use these nonces, because these are random numbers, so they are always different. And therefore, if the receiver remembers the previous nonce that was used in an earlier communication, they will detect that the new one coming in is a replay of a previous one, because they will see the same nonce twice, which is not the way a nonce is supposed to use. So again, these nonces have to be random numbers, and that's yet another application or use of random numbers in cryptography. And as a last application, I want to remind you that in the very last example we discussed in the previous video, we discussed the idea of a session key. A session key is a symmetric shared private key that is generated by one of the parties and then shared with the other party using a hybrid system. And remember that these session keys had to be randomly generated by one of the parties. So here is yet another use of random numbers in cryptography. So in the upcoming video, we're going to discuss some of the properties of these numbers. And in particular, we're going to discuss the properties of randomness and unpredictability and see what they actually mean.